Hi and welcome to E-ZTutoring. Today we're going to be going over how to graph exponential functions. An exponential function is any function where you have your constant and the exponent on that constant is a variable. We'll say x. So y equals 5 to the x. It's pretty basic, but I'd like to start off basic and then I'm going to go a little bit more into detail. So in order to graph anything with a variable as your exponent, the best thing to do is really to make an XY table. So you make an XY table and you plug in some values. Now, the best values to plug in my opinion, are numbers from -2 to +2. So these numbers give you a good idea of what happens on the negative end of the spectrum and the positive end of the spectrum, and 0, which is very important. So if we plug in -2, that gives us 5 to the -2, which is really equal to 1 over 5 to the +2. This is because whenever you flip your number, your exponent turns negative. Or in this case, it turns from negative to positive. So 1 over 5 to the 2 is really 1 over 25. If we were to plug in a -1, we get 5 to the -1, which is equal to 1 over 5. If we were to plug in 0, we get 5 to the 0, which is 1. Because any number in this world, you put a power of 0 on it, turns into 1. Now we plug in a 1, it's easy, 5 to the 1 is 5. And we plug in a 2, 5 squared is 25. Alright, now it's time to graph these numbers, and we have 5 pairs of x and y. We have 5 coordinates. 5 coordinates is more than enough for us to see the graph and to see what is going on in the coordinate plane. So, starting off with -2, comma, 1 over 25. -2 and 1 over 25 is very close to 0, so we're just going to say that that is somewhere around there. -1, comma, 1 over 5 is going to be somewhere around here. 0, comma, 1 is right over here. 1, comma, 5, so 2, 3, 4, and 5 is right there. And 2, comma, 25 is somewhere over here where you guys can't see my hand anymore. So we will just draw an up arrow to say it goes up forever. Now what does it do over here on the left side? Well, the more negative you get, the smaller this number becomes, and it becomes very close to 0. But the thing is, it never actually touches 0. So it will go on forever and ever, getting more and more infinitely close to 0, but never touches 0. So this is actually a very cool topic in mathematics. It's called limits. You guys will learn about this in calculus. But I won't dive into too much detail because your teachers are going to hate me. Now, anyways, this is what the graph does. And as you can see, the more negative you get, the closer it gets to 0. The more positive you get, the higher the number gets, and it will eventually go up to infinity. Now, this is how these graphs act when your constant is a number bigger than 1. Now, what happens when this constant is a fraction? Well, let's see. Suppose that right now we have y equals 1 over 5 to the x. So it's the same as last time, except that the 5 is flipped and we have 1 over 5. So once again, your first step to any exponential function is to make your xy table. You guys already know what numbers we're plugging in. We're plugging in -2, -1, 0, 1, and 2. So we plug in a -2. And this is simple algebra, so I won't go too much into detail about this. I will just go ahead and give the numbers. So we get -2, 25, 5, 1, 1 over 5, and 1 over 25. So now if we graph these new numbers, what do you guys think will happen? -2 comma 25 is all the way up there. -1 comma 5 is right over here. 0 comma 1 is there. 1 comma 1 over 5 is there. And 2 comma 1 over 25 is there. Now, I know I rushed this a little bit. I just don't want to spend too much time on just finding and graphing the numbers. I mainly want to show you guys what the difference is when you change this to a number that's less than 1. So the graph is going to go up over there, and then once again it's going to get very, very close to 0, but never actually touches 0. So what is different? It looks like the same graph, it looks like the same shape, the same curve, except this graph is now flipped. Why? Well, when you have a number that's less than 1, 1/5, the more power that you put on it, the smaller the number gets, because you're taking 1/5 of 1/5 of 1/5 of 1/5, and that number is going to eventually get so tiny that it's going to be like very close to the x-axis. So when you have a number that's bigger than 1, like 5, the more powers that you put on 5, the bigger the number gets and ends up going up really high. So numbers that are less than 1, they will decrease to the right, and numbers that are bigger than 1 will increase to the right. All right, I got one more graph for you guys. Okay, so let's say that now we have y equals 2 times 5 to the x plus 1. Now, this is similar to what we did first, except that we have this 2 and this 1. So these are simple graph transformations around the parent function, the y equals 5 to the x. I'm sure you guys are familiar with this because the majority of the people that are watching this video are in Algebra 2. So just because of those numbers, that doesn't change the fact that we are plugging in our amazing -2 to 2 numbers. So if we plug in -2, it becomes 1/25 times 2, that's 2/25, plus 1, that is 27/25. Once again, simple algebra. I don't want to take up a lot of time in this video doing that. -1 will give us 7/5, 0 will give us 3, 1 will give us 11, and 2 will give us 51. So let's go ahead and plug these in. Okay, -2, comma, 27/25 is just a little bit bigger than 1. -1, comma, 7/5 is also just a little bit bigger than 1, but it's definitely bigger than this fraction. 0, comma, 3 is right here. 1, comma, 11, 5, 6, 7, 8, 9, 10, 11. 1, comma, 11 is right there. And 2, comma, 51 is somewhere on the ceiling. So if we go ahead and connect these dots, it'll look like that. Now what happens over here, because usually it gets really close to 0, but in this case it actually gets really close to 1, not 0. So you can test that by plugging in more negative numbers. You can plug in -100 if you want, and you will get 1.0000 something. So this gets very, very close to 1. Okay, so look at the difference of this graph. Right now, gets close to 1 instead of getting close to 0, that is because of this number right there. That is a vertical shift up 1 unit. Okay, what else do you notice different? Do you remember this number being this high? No, that number last time was like 25. So that actually gives us a vertical stretch of 2, which is this number right here. Because our old graph went more wide like that. So that was our vertical stretch and our vertical transformation up. So I went over 3 graphs with you guys. I hope you guys understand exponential functions now. For more ACT or SAT tutoring, be sure to check out my website, www.E-ZTutoring.com. And I wish you guys the best of luck.